for preparation for week 6 and searching the box for the shiny spot. So let's take a look at the experiment listed in the reference materials. You should read through this, of course, before class, but let's take a look at the basic instructions. I won't do the exact programming modifications, but you are expected to complete those in class. I'm going to open up the timed motion in a separate window. I'll pull that up here, and so this says that you should copy down this code and then change it so that it travels out and around an object. And so let's take a look at copying the code. Again, the code goes from these comments all the way down to the bottom here, and so let's get it to do its thing. Oops. Let's click here. Copy that code. I'm going to switch over to MPIDE as well and put that code in this section of MPIDE. So this is the code that is necessary in order to get your robot moving forward for 1 second. And you should review the code again as I read through it here. There's the initial materials that are up on top, the initialization portions of the program. It establishes that the servo libraries, all the instructions related to servos will be included, and then it actually uses one of those to assign servo left and servo right to our wheel control. The setup program was the other necessary program shown here, and I'll scroll up so that it's shown at the top. It attaches the servos to a specific output from the Digilent UNO 32 and then sends a right forward command. Now, just to be clear, this left and right forward commands, these are functions that are set up down at the bottom. So if we scroll down below the loop commands, you'll see these commands: left forward, left backward, right forward, and right backward. These commands were created for you so that you could more easily control the motion of the robot by using left forward and deciding how fast you want it to go in a range of 0 to 100. Alright, let's take another look at the setup program here. Again, the setup program attaches the servos to the appropriate pins, 30 and 31, and gives a right forward and left forward command. There's a delay for 1 second, and then the right forward and left forward commands are set to 0. And that should stop. This is a point at which you can also verify that your servos are set to 0 with the screwdriver and adjusting them so that they actually stop when given a 0 or a stop command. In this particular one, the void loop program, I'll roll it up to the top again here, is doing nothing, and so it just has a comment in it that says that it does nothing. And then of course below that are the other commands that provide the forward and back motion for the servos. So this is your primary program for this week's activities, and you'll be replacing different sections. In particular, for the first activity, we want you to use the commands for left forward, right forward, left forward, back forward, along with the delay commands to make your robot travel out and around an object. That's your primary activity for this step. So once you've got this loaded up on your UNO 32 and your robot, you should be ready to go. Again, use the verify command to make sure that the program compiles, and then use the upload command to load it to your UNO 32. You should always verify that your serial port is connected to the correct robot, and then make sure that your chip kit UNO 32 board is identified. Those are the first troubleshooting strategies I use when I come and assist students in class, and so if you've done those two first and then made sure that your original code matches, then you can start modifying this section of the code to do what you want it to do. That's the end of the basic time motion activity. Again, make your robot travel out and around something using some strategy, and then move on to the next basic loop functionality program. Basic time motion, then you can come in and take a look at the basic loop functionality. So I'm going to open that software up, and again, read the instructions carefully here. There's only 7 lines, but it's often a mistake students read of not reading this upper section. It says here to change the loop and setup functions to the code below, and so the loop and setup functions here can be copied to the basic timed motion program. So I'm going to pull that program up again, And so here's the basic time motion one. I'm showing it as not being modified, but yours will have been modified. We want to take the void setup and delete that because we're going to replace it, and we're also going to replace the void loop, so I'm going to delete that. Now with the programs we just copied from the left hand side of the screen here, we're going to paste those in here, and so now we've maintained the upper portion, the servo libraries, the servo assignments here, and then added in the void setup. So now the void setup includes only attaching the servos to the appropriate inputs, and then now it uses the loop function to start the robot going forward, wait for 1 second, and then give it a stop command. And again, the challenge here, don't overthink these. Again, we're asking you to read through and understand what the code's doing. The command to make this start and stop repeatedly is simple, so think through this with you and your partners and make it happen. That's really all you need to do for getting the program ready for you to make a program change. And so again, this is the basic loop functionality. Once you've done this, there's a change you need to make in this section of the code that will make it start and stop effectively. That's the end of the basic loop functionality, and then we'll maintain the same program and do the modification for the stop at the line. Open that program as well. Again, we're maintaining the program we've just been working with. I'll pull up the stop at the line sketch. Again, read through the instructions up here. It's going to add a function, and it's going to use light sensor values to start and stop. And so we'll want to make the changes in the code described here, and I'll highlight those changes right here. It says copy void and setup again, and then also add a function down at the bottom. And so let's again highlight the void setup and loop functions. So that comes down to right here, and you'll see there's another command we'll add. So I'm going to copy this section and come back to MPIDE. Sorry for the disarray there. There we go. And in this program that you probably have just modified to do what you wanted it to do, I'm going to highlight the setup and loop sections. Sorry, I'm jumping around a little bit here. Again, I've got setup and loop highlighted. I'm going to delete them and paste in the new versions of those. And again, so we've got setup and loop. It has the attach. It begins something new with serial communication, and then starts the robot moving forward. Down in the loop section, I'll scroll up a little bit here. It gets a light sensor value, so it's going to call a command called getOneLightSensorValue, which we have not included yet. That's the other piece we'll need to add. And then it sets up a counter that prints out the display of the light sensor periodically. And so let's take a look. It has an if statement. It finds out if the light sensor value is less than 35, it should stop. But we're still missing one piece of the code. We'll switch back to the other window and scroll to the bottom. It says you're supposed to add this piece of code. I'm going to go ahead and take the comment with it. Add this piece of code to the bottom. And I'll switch back to MPIDE. And you can, in fact, add it just above our other commands that we're using for left forward and right forward, but it does ask you to add it down at the bottom. So I'm going to go to the very bottom, hit enter, and then paste it in down here. Now again, this command, when you're looking at it, I'll highlight it here, is returning an analog read. It reads the value present at analog 3, and so you want to make sure that your robot's actually connected to analog 3. Your code up here as well says it's going to display analog 3, and so it's a very good idea to keep your wiring matching your programming. And so this is all I'm going to do here. Again, we want you to read through and understand, particularly setup and loop here. Setup and loop, because these are the sections you'll be modifying, and this asks you to, going back to the original question, asks you to change the code so the robot stops at a line when it's detected by the sensor. And the important part here is that you need to establish what the light level is. Within the loop, the if statement here identifies what the command is. You'll be using the serial monitor shown in the upper right hand corner to display that value. You'll have to make sure you're connected to the right sensor and then get the values for the surface of the table. and the blue tape, as well as probably the shiny tape that you'll need later. So get those values, make changes to this particular piece, and make sure your wiring is set up properly so that your robot responds to the correct input and your programming can respond to that input effectively. The last program that we want you to test out and get familiar with, or set of commands, is the stop at a line using while. And so I'm going to open this one again in a new tab so I can see it here. And it again asks you to change portions of the code. So I'm going to go ahead and select the setup, a little bit longer in this case, and all of this code, and I'm going to copy it, and you'll see down here at the bottom that the loop does nothing in this case. So we're going to switch back to our MPIDE and highlight all of this setup and loop commands. So I'm going to delete those. We still maintain, I'll go down to the bottom and show you, we maintain the light sensor information. Since we're going to stop, we're going to need that light center data. So that's still in there from the previous program. I'm going to paste in the new setup and loop and scroll up again. The setup section happens to be longer this time. Alright, so the setup section is right here. It's a little bit longer. It does call the light sensor values, so again you'll have to modify the light sensor values for it to be effective, and then look through what the code does when the light sensor value rises above this. So while it's greater than 35, it's going to this, and that goes from this while statement to this link. Let me show you that a little more carefully. It's going to run this section of the code, while the light sensor is greater than 35. And when it's not greater than 35, it's going to run what's outside that while loop. And so it should stop whenever it's less than or equal to 35. And so they're going to want you to modify this so that it also, let's go back and check their instructions, so that it goes in reverse when the light is detected, when the line edge is detected. So I'm going to switch back to this. And again, those are the types of modifications in terms of cutting and pasting the code. You'll have to work through some of the logic. Again, our hope is that you'll focus on, reading through the setup and loop programs primarily. So these sections of the code are the ones you'll want to work on making slight modifications. Usually it doesn't take much. The effort should be here understanding what the code is doing relative to your robot. So those are the activities. If you get to these points at the end of week 5, you can start thinking about how you're going to use these commands to search the space for that bright shiny spot. Good luck, and hopefully you're prepared for class, and if not, review these after class.